Logic and Venn diagrams. Example. Consider the conditional statement. If you are stopped for speeding, then you will get a traffic ticket. Let S be people stopped for speeding and T be people who got traffic tickets. Here's a Venn diagram for this situation here. Because it's a conditional, the premise is inside of the conclusion. Right, so if the premise is true, then the conclusion is true. Right, so if you stop for speeding, you get a traffic ticket. But notice, if you're in this region right here, it's outside of a stop for speeding. If you get a traffic ticket, doesn't mean that you stop for speeding. Right, and that's the converse. Right, the converse should look something like this. If you get a traffic ticket, then you stop for speeding. Right, and these are different Venn diagrams, as you guys can see. Conjunction using Venn diagrams. For the conjunction, he's a math major and a music major. Let A be math majors and B music majors. To say he's a math major and music major means that he belongs to both sets. This circle is people who are math majors. This circle here are people who are music majors. The conjunction are people who are both. This junction, on the other hand, is math majors, both music and math majors, and music majors. Let F be the set of senators who voted for the Farm Bill and T the set of senators who voted for the tax bill. F is equal to senators who voted for the Farm Bill, T senators who voted for the tax bill. Make a Venn diagram for F and T and shade in the region for which the statement he voted for the tax bill but not the Farm Bill is true. Let S denote the set of Southern senators. Suppose it's true that all Southern senators voted for both the tax and Farm Bill. Add the circle representing Southern senators to the Venn diagram you made in part 1. This circle represents the senators who voted for the Farm Bill. This circle represents the senators who voted for the tax bill. This part right here, the shaded part, is senators who voted for tax bill but against the Farm Bill. Right, this area is within the circle voted for tax bill, but outside of a circle voted for Farm Bill. Now, if we wanted to include Southern senators who voted for both, they have to be included in the intersection or conjunction of the two sets. Right, so this set is a set of Southern senators who voted for both bills. Counting using Venn diagrams. Suppose that 17 tourists travel to Mexico or Costa Rica. Some visit Mexico, some visit Costa Rica, and some visit both. If 10 visited Mexico but not Costa Rica, and 5 visit both, how many people visit Costa Rica? Let M be tourists visiting Mexico and C tourists visiting Costa Rica. Solution. We create a Venn diagram. This circle represents tourists that visited Mexico. This circle represents tourists that visited Costa Rica. Right, so 10 tourists visited only Mexico, but not Costa Rica. And 5 tourists visited both Mexico and Costa Rica. The sum of all of the numbers within the two circles gives a total number of tourists of 17. 10 plus 5 plus n is 17. That means that 2 tourists visited Costa Rica but not Mexico. That means that 7 tourists visited Costa Rica. 5 plus 2. Right, so the tourists that are in this circle, the Costa Rica circle, are 5 plus 2. Example. Suppose that 100 high school students are examined in science and mathematics. Here are the results. 41 students passed the math exam but not the science exam. 19 students passed both exams. 8 students failed both exams. How many students passed the math exam and how many passed the science exam? Solution. Let M denote those students who passed the math exam and S those students who passed the science exam. This circle represents students who passed math. This circle represents students who passed science. 41 students, this slice right here, 41 students passed math and not science. 19 students passed both. And students passed science but not math. And 8 students are outside of these two sets. There are 4 total regions, right? The region outside of the circles, this region here that contains 41 people, the region that contains 19 people, the region that contains n people, and the sum of all the people that took this test is 100, right? So we add all these numbers together, 41, 19, n, and 8, and the sum is 100. Solving for n, we get n is 32. People who pass science and not math, there are 32 people. Therefore, people who pass science are the people in the blue circle. 19 plus 32, and that's 51 people. Venn diagrams with 3 sets. In the Venn diagrams in figure 120, the rectangle represents all highway collisions. The 3 circles show the percentage of collisions resulting from one or a combination of 3 factors: the vehicle, human error, and a road. Let's look at this diagram closer. There is 3 sets here. These are the factors that caused collisions: the road, the blue one, the green one is a vehicle, and the yellow one is a human error, and everything outside of it. So there's some other factors, right? This represents here the other factors. This slice in the center here is the collisions where all 3 factors played a role. A survey asked 110 high school athletes which sports they played among football, basketball, and baseball. The results are given in the table below. So we can fill in the Venn diagram here with the 3 sets. We have football, basketball, and baseball. How many played none of these 3 sports? How many played exactly 2 of 3 sports? How many played football? We create a Venn diagram. We have 3 circles, one for football, the orange circle, the green for basketball, and the yellow for baseball. And fill in the numbers, right? So this number 24 represents students who only played football. This 5 represents students who played football and basketball, but not baseball. This 5 here. 6 people played all 3 sports. Outside of these 3 circles, we have students who played sports other than football or baseball or basketball. So how many people played none of these 3 sports? There were 110 people who we surveyed, and the people who played the 3 sports are these people here in these circles, right? So we just have to add these numbers and subtract them from 110. And there's 31 people who played sports other than football, baseball, or basketball. The number of students who played exactly 2 sports. These are the people who are in this slice right here, the 5 people here, the people who played football and basketball, the 9 people who played football and baseball, and 10 people who played basketball and baseball. Right, so these people, 24 people, played exactly 2 sports. The number of people who played football are the number of people in the orange circle. So 24 plus 5 plus 6 plus 9, 44 people.